Bismillahirrahmanirrahim. Today, inshallah, I'd like to do two examples of hyperbolas. And I have written the questions here for us, and I'd like to bring to your attention that they're different in one critical way. The first one has the y term that's negative, and the second one has the x term that is negative. And I'm going to suggest to you right away that this is going to be a horizontal hyperbola, and this is going to be a vertical hyperbola like this. And I'm going to describe to you how to go about figuring all of that out. If you recall, the general equation for hyperbola was this: x minus vx, the quantity x minus vx squared, over a squared minus y minus vy squared over b squared is equal to 1. And then y minus vy squared over a squared minus x minus vx over b squared equals to 1. And typically this is how it's written. You could say, why don't we just write the x term always first and the y term always second, but typically most people prefer to have the negative sign in the middle, so you have to flip these two to give you the two different versions of the hyperbolas. This is going to be a horizontal hyperbola, it's going to be a vertical hyperbola. Now, that tends to confuse students a lot, which one is horizontal, which one is vertical. And after a while you forget it, and then you get confused. But I'm going to try to suggest to you the best way of sorting that out. The other thing, it doesn't matter which is A and which is B. So those A and B have different connotations for ellipses and hyperbolas. And it does make it different for ellipses, which is A and which is B. A is always the bigger value for ellipses. In hyperbolas, A and B can be equal. And either one can be greater than the other one, so it doesn't matter which one is A, which one is B. It also doesn't matter because, thankfully, the relationship between A, B, and C for hyperbolas is thus: a squared plus b squared is equal to c squared, the Pythagorean theorem. So therefore, it doesn't really matter which one is bigger, which one is smaller, because of the community property of addition over here. So now, how do you go about graphing these? So that's what we're going to learn today, inshallah. So let's do the first one over here. Now, the first thing I do is you find the pseudovertex, and the pseudovertex is going to be the center of the hyperbola. Okay, so that's going to be the pseudovertex. So pseudovertex, as you know, is our affectionate term. It's properly called the center. And in this case, it's going to be Vx is 0, so it's going to be 0, and Vy is -1. So the pseudovertex is going to be this. So I'm just going to graph that, and that's right here. Let's label some of these. That's 2, and that's 4, and that's -2, and -4, and that's 2, and that's 4, -2, and -4. So that's our pseudovertex. So let's read that. Okay. So that's the center. And from there, you want to create that the hyperbolic rectangle, as we affectionately call it, right? So to make that hyperbolic rectangle, you need A and B. So and now it doesn't matter which one is A, which one is B. The way I do it is I look at the x term, and the denominator for x term is 25. Okay, so in that case, I say, okay, if you take the square root of that, I'm going to go 5 units from here. Okay, I call it A. So from this we get A is going to equal to, I'm just going to do it over here. So A squared is 25, so A is 5. So I'm going to do 5 units from the center. 1, 2, 3, 4, 5 in either direction over here. Okay, so that's 1, 2, 3, 4, 5 in either direction over here. So that's going to give me the two corners of the rectangle. And then I'm going to look at the y term, and I'm going to look over here, and then in the y direction, in the vertical axis, I'm going to go 4 units up and down like this. So I'm going to go 1, 2, 3, 4 over here, and 1, 2, 3, 4 units over here like this. Okay, so that's going to allow me to make that rectangle. Okay, so let's make that rectangle. Let's use maybe a grayish type of color. So I'm going to make that rectangle like here, like this. Okay. Now, at this time, if you don't know if it's a horizontal or a vertical hyperbola, that's okay. Now, when you would do these, you would make dotted lines, okay? And then I'm going to connect these over here, the four corners like this, and those are going to be the asymptotes. Okay, like that. It's kind of okay. That's close enough, huh? Let's try to do it here. Eyeballing, right? So, and here is just the other asymptote over here, and that's the other asymptote over here. It's kind of tough to do like that. Okay, like that. Okay, now we got our asymptotes. The only other thing that we have to figure out, okay, let's see if you did not know if this was a vertical or a horizontal hyperbola. So then you have to figure out, okay, is this one going to be like this, right? Or is this one going to be like this, right? Okay, that's what you're going to have to figure out. Let's see if you didn't know and you wanted to figure that out. How would you go about doing that? So imagine for a second, let's pretend for a second if this was going to be like this. If you, let's say you didn't know, and this was going to be a vertical parabola like this, then if you take this, the center point over here, the center point being in this case 0, -1, if you plug in 0 in this equation, if you plug in 0 over here, you should get this value and this value, right? So in other words, if you plug in 0 over here, you should get something over here. You should get two answers in over there, correct? Now, or if, for example, if you pretend that this was going to be a horizontal parabola like this, okay, then these would be the two vertices, okay, and then if you plug in the center value, if you plug in the pseudo-vertex value, which is 0, -1, you should generate this value and this value over here. If you plug in the 0 over here, in this case, there's nothing that corresponds to over here, right? If you plug in 0 over here, there's nothing that corresponds to the y. There's no corresponding value for y if this was a horizontal parabola, hyperbola. On the other hand, if this was a vertical hyperbola, if you plug in 0, you should get those two values, that's this one and this one. Okay, so let's see what happens if you put this value, the Vx, in here. So in this case, the Vx happens to be 0. So if you plug in 0 over here, let me rewrite this equation: x squared over 25 minus y plus 1 squared over 16 equals 0. If you plug in equals 1, it can't be 0, and then you're in trouble. Equals 1. If you plug in 0 over here, this whole term is gone, right? In this case, right? In this case, the Vx happens to be 0. So now you have negative, okay, y plus 1 squared over 16 equals 1. So I'm going to multiply both sides by 16. I get negative y plus 1 squared equals 16. Divide both sides by -1. So I get y plus 1 squared equals -16. Now, then you would take the square root, but then you realize you have a square root of a negative number, and since that is haram, you can't take that, and you get imaginary numbers. That means there's no corresponding values that go with x equals 0. In other words, for this x value, the domain, there's nothing that corresponds in the range. Since there's nothing in the domain here, then that must mean that this is a horizontal hyperbola like that. Okay, so that's how you do it. Now, you can call this the pseudo-vertex test. Pseudo-vertex test. So that's what I do. So you do the pseudo-vertex test and to figure out if you put the Vx in the equation, if you get legitimate values, that means it's a vertical one. That means there are two values over here. And if you put in pseudo Vx in the original equation, if you get like negative squared sign, that means there's no corresponding y values, so it has to be horizontal. So this, therefore, is going to be a horizontal hyperbola, and it's going to go approximately like this. Now, if you were to really draw this, you want to get a couple more points to make it, more legitimate sounding, like that. But we're going to put it just kind of like this for now. Okay. The only other thing that we have to do over here is we have to find the focus. To find the focus, you have to find c. Now, c squared is equal to a squared plus b squared. So c squared is going to be 25 plus 16. That's a squared plus b squared. Okay, so that is what? 35 and 41, right? So c is going to be square root of 41 if I did that correctly. So that's going to be somewhere over here. All right, right there. So that's our c. Let me just kind of highlight that, okay? So the c is going to be from here to here. That's our c, and that is square root of 41. That's 6.4 or something like that. I'm guessing it's going to be. I'm just guessing that it's 6.4. So that's the value of c, and the full size is going to be therefore from here the coordinates is going to be square root of 41, and y value is going to be -1. And on this side, it's going to be 6 over. It's actually going to be somewhere over here. So a little bigger than the 6, right? So that's 5, and that's like over here. That's the other full side, negative square root of 41 and -1. So those are the two full sides. So the two full sides, if we were to write them over here, if we're trying to find the place, the first full side is going to be square root of 41, -1. And the second full side is going to be square root of negative square root of 41 and -1, like that. Okay, so that's how you graph it. Now let's do the second one over here with the same analogy. Now in this case, the y here is squared, so and x is over here. So but the same applies. The same analogy goes in terms of the way you graph these. Okay, so if you recall, the first thing I do is find the center or the pseudo-vertex. In this case, it's easy because it's 0, 0. So this one is centered over here. That's the pseudo-vertex, Vx, Vy, and that is 0, 0. Okay? And then you make that rectangle, correct? So let's make that rectangle. I used brown this time, so let's just do the same thing. Maybe a little lighter. Okay, so here we go. And then you go from the pseudo-vertex, you go square root of 25, 5 units in this direction. Well, so 2, 3, 4, 5, right there. So that's 5, 0, and 1, 2, 3, 4, 5, -5, 0 over here. So that's like there, and that's like there. And the y direction is you do square root of 3. That's 3, 1, 2, 3 over here, and 1, 2, -3 over here. Okay, there we go. So now we can make that rectangle like this. It's not the best one here. -3 over here. It's approximately. And again over here. Okay. All right. Then I can make my asymptotes. Here it is. You got an idea? How about that? Pretty cunning, huh? All right, here we go. Asymptotes. All right, now we have the asymptote. Now we're ready to graph. Now all we have to do is we got to figure out if this is going to be like this or it's going to be like this, right? So we'll do our pseudo-vertex test. So the pseudo-vertex is 0, 0. So if you put in 0 for x, let's see what happens. If you put in 0 for x, you get y squared over 9, and the whole term disappears, right? 0 over 25 is equal to 1. And then you get y squared is equal to 9, and you get y is plus or minus 3. Ta-da! See, now you get this. So x is 0, y is 3, and x is 0, y is -3. So we get two legitimate values. So since you got two legitimate values over here, then you must understand that this must be a vertical hyperbola like that. Okay? So there we have this. So now we can say the vertices are the following. The vertices is 0 plus or minus 3. Okay? And all we have to do now is we have to find the foci. To do that, you have to find c. C squared is a squared plus b squared. It's 9 plus 25 again. Or again for 25 again, that's like 34. So c is square root of 34 in each direction. So square root of 34 is almost 6, right? If I did this correctly. Square root of 34. 25. So 3, 4, 5, 6. 4, 5, 6. Looks like that. It's between 5 and 6. Closer to 6. Closer to 6 right here. Okay, so that's the foci. So the foci is going to be square root of 34 and 0. And that's the first one. Let's do it neatly here. Square root of 34 and 0. And the second foci is going to be negative square root of 34. I'm sorry. I hope you caught that. X is 0 and square root of 34. And F2, X is 0 and Y is square root or negative square root of 34. And those are the foci. So we found the foci. Okay, and we found the vertices, which were over here. That's the vertices, okay? And now, the only thing that we have not done over here is we can figure out the transverse and the conjugate axis. The transverse axis is the axis between the two foci, so that's the transverse axis over here. Let's call it transverse axis. And finally, this is going to be the conjugate axis, the non-foci axis. I should erase this over here. Okay. So that's the conjugate axis, like that. Okay, transverse axis. So the conjugate axis was 2 times this value over here, which is 10. The transverse axis 2 times this value over here, which was 6. There we go. And that's how you do this. So the questions will ask us to find the vertices. They will ask us to find the foci. They will ask us to find the length of the transverse axis and the conjugate axis. And the transverse axis is the axis between the two vertices, and the conjugate axis the other way around. The one thing that we have not done yet, which we'll do in the next example, is the asymptotes. And we're going to focus on that. I'll give you a little bit more trickier examples with the next time, and we'll elaborate on this next time then, inshallah. Until then, as-salatu was-salamu ala rasulillah wa ala alihi wa sahbihi. Assalamu alaikum.